Hello and welcome to another CAD video. In this video, we are going to talk about SolidWorks Weldments. Incredibly useful if you're doing anything like machine frames. I've seen it used to do a car body for like a mini Baja competition that happens a lot in engineering schools. Fixturing, tooling, all that cool stuff. So, Weldments are an incredibly useful tool. We'll go over sort of the basics in this video. And then in a future video, I've got planned to sort of go over some of the more complicated-ish things. The cool part is there's not really a ton that actually is complicated about weldments. So let's go ahead and get started. I'm gonna create a new part. Okay. And a weldment in SolidWorks is effectively just a sweep, but it's a sweep with specific parameters assigned to it. So with that in mind, knowing it's a sweep, I'm going to start out not with a feature, but I'm going to start out with a sketch. And to sort of keep this first run through simple, I'm just going to create a rectangle. And this is going to end up being tube steel. So I'm going to make this rectangle fairly big because tube steel has kind of got big dimensions. So I'm going to go 2 feet by 4 feet just to, give us enough sort of size, to see what's going on. So I've got a sketch, I've got a rectangle. This is going to end up effectively being a sweep path for the structural members of the weldment to follow. So what I'm going to do now in order to get the weldment in, I'm going to come up to the SolidWorks menu up in the upper left-hand corner, and I'm going to go to Insert Weldments, and I need to insert a weldment first. And that actually doesn't do a whole lot, except in my feature manager on the left, it adds a weldment feature. Now that that is there, I can actually start creating the actual steel pieces, right? So I'm going to go back up to Insert Weldments, and now I'm going to insert a structural member. And it's going to pop up with a structural member here, in place of my feature manager. And I've sort of done some of this before. These came up originally on a brand new install as blank, but under standard, I can choose a bunch of different standards that come pre-installed in SolidWorks. As we get more advanced, if we finally use this tool a lot, we can also create our own standards. But for now, I'm just going to go with ANSI inch, right? Then under type, it has a bunch of preloaded. So for instance, I can select angle iron, and then under size, these are sort of preloaded angle iron profiles it has. And again, I could pretty easily add to this. If, 1 by 1, 2 by 2, or 3 by 2 is not an angle iron that I use a lot, I can add to it. And we'll go over that in a future video, sort of creating our own custom ones. So what I'm going to do for this, just to sort of demonstrate, is I'm going to pick square tube. And then again, under size, I can do 2 by 2, 3 by 3. I can also do, rectangular tube, right? And it's got some built-in stuff. And these are just the defaults that came with a fresh install of SolidWorks. But I'm just going to grab the 2 by 2. And then under groups, I'm going to highlight this so it's blue. Click here. And what this wants is a series of lines, curves, splines that it's basically going to use as a sweep path for the 2 by 2 steel members. So if I come over here to my sketch now and select one of the lines, it thinks for a little second, but then it drops. I can zoom in a little, and you can see the yellow preview is the steel member. I can rotate even, is the steel member that it's going to drop in, and it's grabbing this 2 by 2 defines the sketch. So if I look here, you can see sort of in gray the sketch of the profile that it's using for the sweep. So realistically, all this weldment is a sort of pre-canned sweep. So the profiles are saved. We don't have to sketch our own tube steel to sweep it around in the ways that we want. So with group sort of selected here still, I'm going to go ahead and select the next line around, the path. And notice it drops a yellow preview. And in this case, because there's a corner here, it knows that it needs to miter the corner, because as I look down here, now underneath settings in my left side, I have a bunch of options. So apply corner treatment is checked, and it's telling it to miter the corners. If I select the second option, which is an end butt, notice that the sort of left-hand piece of steel got longer, this one now butts up to it rather than having a mitered corner. Um, if I select the other option, the first one that I selected gets cut short, the second one overhangs. So if I come now and select the rest of my rectangle, again, since this top line was selected first, it's the one that gets cut short. The right hand now got cut short, and this one is, stops at the first one I selected. So we can flip between them, select here, right? It pops that preview back and forth, miter it, because miter is kind of good. Um, Now one thing that I don't typically do is this merge miter bodies. I sort of want to leave that alone because it gives us more options later on when we sort of go to detail this thing out for actual building. But when it comes to a very simple weldment, um, really all it takes now is to accept this. And I have a weldment, right? I've got four steel members making my rectangle. So now there is an issue with this, and this is sort of the one of the cool features of a weldment. I might be a bit of a nerd in saying that, but I think it's kind of cool, is that a problem here. If I select this line and I'm going to select the other line, these are my sketch lines. They still show up in gray because I've got the sketch here showing. So if I just select those and I come up here to my evaluate and measure between them, millimeters is still on because I was in doing some things with the SolidWorks certification tests, which work in millimeters. So my settings were off. But go back to inches. So there's my 4 feet. The 4 feet though is what I sketched, and since the tube is a 2x2 tube, which I grabbed, so it's an inch on either side. So I've got an inch here and an inch on the other side. So my entire weldment now is 50 inches from end to end, which could be okay, could not be okay. If I really truly want to keep that 48, I need to right click, and I could do this up front, but I wanted to show sort of how it comes out by default. So by default, it's going to center that profile, and if you look again at the grayed out sketch, that's what it's sweeping, and it defaults it sort of in the center. Right? There's a center point in this sketch to locate it. I can change that very easily by coming down here at the sort of the bottom of this settings area and clicking locate profile. And now what it wants me to select a point that it is going to use as sort of this origin point for the sweep. So I can select, let's say this point here that I have highlighted would be the center point of this arc for the corner. If I select that, my entire profile moves now, because that's now considered the center of the sweep, and it'll be center if I rotate, right, so we can see every corner. It'll rotate it, or it'll move it for every member along that path. We can see we moved further in on all the sides. Most commonly, or maybe at least in my experience using these weldments, most of the time, what I really care about is the outside dimension. So most of the time, I'm going to grab one of these dots instead, and I can change this at any time just by clicking Locate Profile again. And if I click any of these outer dots, which are here, this sort of star shape, it means that when this sketch was created by the folks at SolidWorks, these are just points in space. And I'm sure if we look at the sketch details, it's constrained, so they're in line with the sort of the top edge and the side edge of the tube. But if we select one of those now, I'm completely inside my 48 inches. So if I accept that now and sort of go back to the top view, I'm completely inside that 48. So if I even measure to verify by selecting now the edges of the steel instead of the edges of the sketch, I can again come up to evaluate and measure, and I've now got my 48 inches end to end, steel to steel. That's incredibly useful, especially if we need to, pardon me, if we need to add add tabletops or this head needs to fit in a specific area. Like I said, most of the time I care most about either the outside dimension, which is most common in my applications, which are like machine frames. I'm gonna design it for the outer dimensions. Um, or even the inner dimensions sometimes, depending on what we're doing. But usually the center, which is the default, is not really good. Plus, it's really hard to measure the center. Like imagine, we give this to a welder to put it together to fabricate this thing. It's going to be incredibly difficult for him to measure things off of center lines in the middle of space in the middle of a piece of tube steel. So usually I end up relocating to one of these sort of corners out in space. That way, one way or another, my weldment ends up entirely um, within the dimensions. And then I can create my sketch to true dimensions. I don't have to worry about, well, okay, how thick is the tube? I need to add an inch to each end and that kind of thing. So that's one of the key tricks to sort of getting the most out of these weldments. Now, we can also modify. So I'm going to go in and modify this sketch. And let's say I want a corner bracket. I'm just going to draw a line somewhere in space. And again, this I'm just, well, I am going to give it a 45 degree just to make sure we're true 45, but I'm not going to worry too much about the length just for demonstration. So I've now got a corner in here, and I am going to now modify my my original weldment. I'm going to create a new group because I want it to still be 2x2 steel, but I'm now outside of sort of the main path of what that steel is doing for me. So I've created a new group. The original group is still there. If I click on it, it's yellow. New group. Nothing is yellow because I haven't actually selected any lines for it to extrude along. Um, so we've created the new group, and we now need to select a path, which is that corner that I just made, or that 45 rather. And notice now with a new group selected, it has dropped a preview in for me. It's automatically mitered it to butt up flat against the existing tubes. But the one thing that it has not done for me is notice it again defaulted to the center, which means that if I rotate it right, I'm halfway above. So I also have to relocate the profile. And in this case, I'm going to select the top because this time, if for this sort of application for a corner brace or something to that effect, the center dimension is probably what I would dimension. Maybe not on a drawing, but at least when I'm creating my sketches, I would probably leave it centered, but select one of the points on the top so that it's flush with the rest of my weldment. So that's a pretty simple. So a new group gets us the ability to add weldments. We can also use it to add legs. So for instance, I'm going to roll back my model because I want to create a 3D sketch this time. So I'm going to create a 3D sketch and I'm going to draw a line, actually lines. What I really want to do is I want to make vertical. Um, I want to make verticals here. So I'm going to make a vertical and we're going to turn this sort of 2D weldment into a 3D frame. So let's make verticals all along. And with 3D sketching, the trickiest part is angles because if I sort of draw an angle, we could get some weird. See if I can make it sort of break the way I'm thinking. It's not always real clear what plane 3D lines are going to end up in. So best is to pay attention to the XYZ coordinate system down in the lower left corner. And if you don't get sort of the orientation for your lines that you want, you can always select that. And one of the constraints over here is along Z, which will force it to be in the Z direction with the rest. So I'm going to also select all of these and set them to be equal length. So I can set them to be equal length. And let's give them a length. Let's just go a foot tall. Okay. And then, and actually, I'm going to modify that 3D sketch because as part of that 3D sketch, I can also sort of create a frame along the top uh, from point and just by drawing lines from points to point. And I don't even need to create reference geometry to do that. Normally, I would sort of ahead of time create a plane up here, but I could do all of that just in the same 3D sketch without creating a reference plane. So now I've got a box, a prism, a rectangular prism. I can roll my model back forward. The old frame pops in. I can now modify this tube. I can edit the feature. I can create another new group. Anytime I create a new group, the limiting factor is the size and is this stuff here. The standard, the type, and the size for any group will be the same. If I wanted to change, and I'll do that in a minute, if I wanted to change and use, say, angle iron, and I'll do that, I'll use angle iron for these verticals. Then I would need to create a new entire weld structural member. Anytime I want to reuse this 2x2 steel, all I need to do is add a new group, and I can create as many any combination that I want. So I'm going to go ahead and continue here. And notice again, I'm centered. I'm going to locate my profile. So locate profile. And in this case, I want it to be below and inside that top. So I've got the outer dimension and the top. Now, where is my sketch? Sketch is here. So it's going to be that point out in space. And now I'm below and inside my profile. So if I wanted this whole table, whatever this is, to be 12 inches tall, well, I would have to modify the first group. So let's do that while we're here. Edit, and I can always go back and change groups. So I'm going to change this group, and I'm going to locate the profile and choose this lower dot instead. That way, and I need to do the same for group number 2, that little bracket, or brace rather, and locate. And grab that center point at the bottom. This now is flush with the bottom instead of flush with the top. And accept. So now, because I've sketched this sketch at 12 inches tall, I should have 12 inches exactly from top to bottom of where my steel will be. So measure, and I've got my 12 inches. So that's sort of why I would go through the hassle of um, of dimensioning and locating the profiles to the right spot. That way, I can dimension my 3D sketch or even my 2D sketches. I can dimension them true to size, and then it really just depends on how I locate the profile as far as how that size measures. So now I'm going to add a new structural member. So I'm going to file, insert, weldments, structural member. Okay, I want to change to angle iron just for the sake of demonstration. Let's go 2x2, and in groups, I'm going to create a new group, and I'm just going to start selecting and selecting and selecting. Now we may end up with an issue here because I do not believe there's a good way to rotate these. Let's see. We may need to rotate here. So if I click a 90-degree rotation, that rotates, but it will rotate them all. So what I really need to do is I need to clear my selections. I'm going to select one of my verticals. I'm going to rotate that 90 degrees. Then I'm going to create a new group and select. That one's already lined up where I want it. Oops, I accepted too fast. Edit, new group. So I basically need a new group for each leg because each leg is going to have a slightly different rotation. So this one should be -90, I believe. Oh, it won't allow -90, so 180. Nope. Just 90? Nope. Must be 270 then. There are only so many 90-degree choices in 360. So good. Then we add another group and select the last leg and give it rotation. Is this the one that's going to want to be 270? Whoops. too happy with the enter key. So my group 4, rotate 270. No, no. Figuring out this stuff on the fly. 180 degrees is what I want. There we go. Okay. So we've now got the issue where it's sort of protruding into existing steel. That is not good. So we need to edit the feature, and um, we basically need to trim it at um, the ends of the existing tube steel. And as I do these videos on the fly, I'm suddenly finding myself needing to remember exactly how to do that. I do believe that's under Insert, Weldments, Trim and Extend. So I want to trim this, this, and this. The trimming body, or trimming boundary rather, can be either a face plane or a body. So a face, I would have to select the top and whoop. Okay, didn't actually select anything. We're good. The faces, the flat here is what I would have to select for a face. If I select body, it's just going to select that entire part. So um, tricky thing here, I do believe, working from memory, if I select a body, I'm going to try this. Oh, do not trim. So I need more. I need to select all the bodies to trim. That's right. So select them all. And if I select, okay, we're okay. There are some hidden disadvantages in the weldment setup with trimming. In certain cases, you can end up where this will sort of be, it'll look like it's machined to this curve, and it'll sort of extend all the way up to this flat where it actually would touch, which, isn't really true to life. And in fact, the way we've trimmed it isn't really true to life. We'd have to kick this in order to line up and make it a leg. So for instance, maybe in my trim, was that a feature that I missed? There we go. So this here, allow extension, if I select this other option here with a coped cut and accept, notice it's cut it out really funny looking because it's trying to match the curve here on the edge of the existing tube steel. So that's a thing to watch out for. It can be useful in certain circumstances. A lot of the time, especially if we're just sticking with tube steel, we want to leave it flat and then we'll just weld the gaps. So what if we click weld gap? I've actually never used that. I'm going to leave that off for now. But so to add the bottom one to trim, all I really need to do is make sure I've got selected here my trim bodies, and again select the bottom group of weldments, and it'll also trim off the bottom. Now, if I want to, obviously this angle iron, that's a lot of gap to try to weld. If I want to, I can also come in here and I can um, edit this feature and change that. So angle iron's not the best choice for that kind of corner. Let's go back to a square tube. For some variety, let's make it, say, 3x3. Okay. Now, we're going to need to close and actually I can delete groups and just sort of redo things to make this work better. So I'm going to locate this profile because I don't need rotation anymore. We're doing with square tube. So I'm going to set my rotation to 0, but I'm going to locate the profile to that corner. And that's still going to be a lousy weld, but I hope that you are able to sort of see the difference in what I've got going on here. So new group there. Again, locate the profile. And in this group, we're going to locate it here. And I'm just going to leave it with the 2 for now. Trim extend fails because I deleted the angle iron, but I need to go back and retrim now. So I'm going to go back to file, or rather insert weldment, trim, bodies to trim, are my two legs. I'm going to trim to the bodies here, 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 and here. And we'll trim it nice and flush. Uh, yes, and that's because I had bodies selected. It cut it off. There is no body to cut this little tab off. So if I go back and edit and I clear selections and go to face and select the top and bottom faces, I should be able to get that to cut it flush. There's also an option I noticed in one section called Allow Extend, which we may also have to deselect, but I'm going to accept that, and that just selecting the faces cut it flush for us. So again, maybe not the best. We've got less of a gap than we did with angle iron. That should maybe be able to be filled with weld. I am certainly willing to admit that I am not an expert welder. In fact, usually when I do this sort of work, I sort of, give them a drawing of the frame with the key dimensions and allow the welders to do their magic. They're way better at it than I am, and I'm willing to admit that those guys are good at what they do. So that's sort of the simple creation of a weldment. So I'm going to go ahead and save this as a weldment, and I'm just going to call it weldment for purposes of this video. And the weldment, now that we have one, gives us some really cool things that we can do as far as sort of explosions and other things. So normally we can't explode a part, but because we've added that weldment feature, this thing has now it's effectively a multi-body part that we can explode. So I can select and create an exploded view, even though this is one part file, not an assembly. Normally we would explode assemblies, but for now I'm just going to do that. But we can create the same type of exploded view for how this thing goes together as we would with a full assembly. And that's one of the key features of a weldment. So turn my exploded view off, collapse it, but that gives us, the ability to explode this weldment to show how it goes together. Then, one of the other cool features, once I come in and make a drawing from this thing, click OK. OK. So the other option to sort of let's just do an isometric view for now. The other option to sort of get this thing in a design that we want would be to do it as an assembly. Create different parts for the different lengths with mitered corners. But that can be sort of a nightmare as we have all of those files to update to make a change. Like you saw in the video how quick it was for me to change sort of the entire look of how this thing goes together, the alignment of the profile, all that good stuff is a bit of a nightmare if we did these as separate parts. This way, it's much easier to make changes without having to change anything. And then but the other benefit is that we have the option to create not a bill of material, because this is, as far as SolidWorks is concerned, one part. So if we created a bill of material, let's do that. Insert tables, bill of material. Drawing view is that one. Yeah, that's all good. So if I bring this in, oh, it actually does. It actually does. So we've got one weldment. This is a different format than I'm used to. It used to just drop in the weldment on one line, but still, this doesn't tell me a lot. Like, yeah, it's square steel tubing. I got 4 of them, but I don't know what that means to me, right? I mean, so better for weldments specifically is if I insert a table, I have with weldments a cut table, or a weldment cut list rather. I got the same things. I need to select the view. There's some options here. Usually the default for me is good enough, but if I click this guy, I now have, excuse me, I have a cut list now telling me I need a square tube 24 inches long. I need 4 of them. I need 4 square tubes 48 inches long. This must be my angle because I don't remember a weird dimension like that. So that's probably my angle brace. Square tube, those are the two legs that are in there, right? I need two pieces at 8 inches long. I can also, in the cut table, I do believe, and again, this is sort of me, uh, designing on the fly, but we should also be able to include, I'm just going to go ahead and delete this and see if it's an option. We should be able to also include miters in our cut table. So I'm going to delete the bill of materials too. So insert tables, weldment cut list, drawing view, that one. And let's see, does it give me an option to include? All right, I don't have any other templates. Anchor points, configurations, keep missing items. We don't want to do that. Start at 1. There are options buried, and as I think on the fly, there are options buried to get us. Uh, there we go. So insert a column to the right. I see where the options are now. So when I select a column, right, it's telling me over here on the left, it's a cut list item property, right? It's an automatic thing. It can pull out the length and I can give it a title. So I can select a new column that is empty. I can give it a cut list item property. Rather than length, I want to give it angle 1. And I want to call it angle. I can leave it angle 1. I can give it some other name. But now I've got a 45-degree angle. So now I know I need 4 square tubes, 24 inches long with a 45-degree angle. I can also add another column because they've got miters on both ends, right? So insert a column to the right. Again, select that column, give it a cut list item property, angle 2, and now I know I've got angles on both ends. So if I were to, if one of these were to be a butt where it's flat, I'd have 0 and 45, right? So the cut list really works like a bill of material for a single part that is our weldment. I did this on A4 paper. I usually work on B size, so it's a little bigger, and I have more room for this kind of stuff. But hopefully that gives you the idea of sort of some of the power of the weldments. So in future videos, I'll go over some of the other features, some of the cool things we can add in that are not necessarily strictly tubes. I also have a video plan to show how to create custom profiles. So we saw that, there are basically 3 tube sizes that come default with SolidWorks. I like to create custom profiles because one of the things that I end up using weldments for most is not actually welded frames. What they are really, really, really good for is for 80/20 type aluminum extrusion, sort of bolt together machine frames. So I've got a video planned where I will go over how to create and add a custom profile, and I'll do that using sort of 80/20's profile so we can do an aluminum extruded frame here, and we can see how that, all the same stuff, except for the fact that the corners are not welded in 80/20. All of the rest of the stuff absolutely applies the same. So that is all for this video, sort of an introduction to weldments, getting the cut list in, making some changes to the model. Hopefully this was helpful to get an idea again of how powerful a weldment can be instead of the alternative, which would be to do this as an assembly with all different pieces. So thank you for watching, and I look forward to seeing you again in a future how-to video.